Welcome to normal distribution. In the normal distribution, we need to understand how to read this normal distribution table. So the probabilities under normal distribution have the following properties. Whenever we're dealing with a normal distribution, you need to understand that it is bell-shaped. The bell shape looks like this. Then each of these quadrants are 50%. So this means asymmetrical. Meaning the left side mirrors the right side. The area under graph is what? Is equal to 1. And the tails are infinite, they don't touch the base. All right, so that is what is happening. So how do we read the normal distribution table? So to standardize the figures under the normal distribution table, we're going to consider the following formula. X minus mean over standard deviation. So suppose we're given values of Z like 1.23. The way we're going to read this in the table, you go under 1.2 and 0.03 where they meet. This is our probability. So let's go to our table here. 1.23, you go under 1.2 and 0.03. What is the reading that we have there? 1.2 and 0.03. This one here. What is our reading here? 0.89065. Okay. Now I want you to help me. Give me the reading of 1.67. Another one, 1.96. Any of these two. Pick one, any.
One point 96. 0.97500.
1.96. So 1.9 and another 6.
Yeah. 0.9750.
Yes, this one here, 0.97. Excellent. How about 1.67?
0.95254.
We'll go under 1.6 and under 7.
0.9554.
All right. So this is reading the normal way. Now, if I ask you to read from inside the table, for instance, I asked you to give me the Z for 0.97500 here. You add this to 1.96 and 0.06. Okay. So give me the Z for this probability. 0.91149. What is a
1.35. 1.35.
1.35? So 1.3 and 5 there, correct. How about what is the reading for 0.9901?
2.33.
2.33.
Mm.
So sometimes you may not have the exact one. You will be asked to find the closest possible. For instance, I asked you to look for the Z for a probability of 0.9 0.99110. Which one would you give me?
2.37.
The closest is this one, 111, right? So you're going to get 2.37, correct. So you get the closest and narrate it in there. So far, we're together.
Yes.
So whenever you're not given the exact one, you get the closest possible. Okay, so now let's actualize what we're talking about there. So we are told, for instance, that we're supposed to find and the probability Z is greater than 1.23. A bit of Z is less than A3. So if you're directly asked to find the probability X is greater than 1.23, you first illustrate and you put 1.23 here. So greater means shade to the right. So let's read 1.23 from the table. 1.2 under 3. What is the reading? 0.89065. So from here to here, 0.89065. 89065.
I
So
don't
that's
really understand how it works.
pardon?
I don't understand how the graph is working.
Okay, so the readings from the table here are literally giving you the percentages from 0 up to the end. So for instance, if I told you the reading for 1.23, it is 89% or 0.89065. So what that means is that the reading from here to here is about 89% from here to here. That's what it means. Those percentages there are actually areas under the graph. So if I asked you, what is the reading for Z 2.0? So it means the reading from here that we're looking for, from 0 up to 2. This area here, we need to read it. It should be above 50%, obviously. So we go under 2.0. So 2.0 is somewhere here. So this is 0.97725. So it means that the reading from here to here is 0.97725. So it's about 97%. So meaning the remainder that you're going to remain here, to get it, you subtract from 1, because the whole area from the properties I gave you should give us what? 1. So let me use some logical examples. If, for instance, the area from 0, okay, 0 is always in the middle, maybe it's -2, okay, and this is +1. So from here to here is 0.8 what? 413. This area is 84%. How do we find the remaining area?
Less it with 1.
You less it with 1 to get the remainder. Why?
Because the whole area is like
1.
100%. Like, no 1.
The whole area is 1, yeah. Suppose I told you that the area from here to here is 2%. What is the remainder here?
%98.
98%, correct. Because the total must add up what? 100. Now suppose the area from here is 5%, and the area from here to here is 2%. What is the area in between here?
93.
90 what? 2.
Yeah.
All right. 93%. Because this we've removed, that we've removed. So I need you to just use logic here. So if you're given a scenario question where we're told that mean is 10, standard deviation is 3, find the probability that x is greater than 16. So I need you to use 4 steps. Number 1, illustrate. Number 2, shade. Number 3, standardize. Number 4, apply. So the shortcut I'm giving you is so let's do this. So 0 is here, and we are looking at 10 is in the middle. Our mean is always should be in the middle. So mean 10, and we are given 16 here. And we're asked greater than. Greater means shade to the right. So step 1, illustrate. 10 and 16. Step 2, shade. Greater means to the right, less means to the left. Before standardize, the formula for standardizing is what? X minus mean over standard deviation. So we have 16 minus 10 over the standard deviation, which is 3. What is 16 minus 10? It is 6. 6 divided by 3, we get what? A 2. So meaning now you apply. Let's check what the 2 means in the table. So you check here under 2. What is the reading for 2? 0.97725. 0.97725. So 0.97725. That means from here to here is 0.97725. So how do we get the shaded region?
Yes, it's 1.
Subtract from 1. So here the probability of Z greater than 2, if you want, you can say the probability of X greater than 16, because 2 and 16 are just the same, because this is in terms of Z. We're going to have 1 minus 0.97725. So the difference here is giving us 0.02275. So who wants to try? Let's do another one. Suppose you are asked the same parameters. Mu is equal to 10, S is equal to 3. Find the probability that X is less than 13. So using ISA, what are the steps do we use? Number 1, illustrate. Our 10 is here. Our 13 is here. Step 2, shade. So we're saying less than, so we're shading to the left. So our application is that whenever the shading is big, we read direct from the table. It's more than 50% in short. So in this case, we're going to standardize. So we know that mean is at 0. How do we standardize that? X is equal to what? Mean minus mu over standard deviation. So 13 minus 10 over 3. We're going to get a 1. So 13 is equivalent to 1 in this context. So let's read what the 1 is, what we know from here to here. So 1.0, what is the reading? 84,134. So 84,134. Do we subtract from 1 or read it directly? We read it directly because it's a big shading. Whenever the shading is big, we read direct. If the shading is small, we subtract from 1. Okay. The same question, mean is 10, standard deviation is 3. Suppose we're being asked, find the probability that X is less than 3. Oh, less than 3. So let's illustrate. My mean is there. So here we have 10, and here we have 3. Less than 3. So less means we're shading to the left. It's a small shading, so automatically whatever we're going to get, we subtract from 1. So how do we standardize? Mean minus mu over standard deviation. So our mean is 10. Our x is 3 minus 10 over the standard deviation 3. So it's minus 7 over 3. What is 7 divided by 3? 2.33. If it was 2.66, we'd round off to the nearest, which is 2.67. So negative. The negative just shows you that we're on the left side of 0. So negative 2.33. Let's read 2.33 from the table. Please help me find the reading. 2.33.
Two point what?
2.33.
0.99010.
So 2.33. 990, 10.
Yeah.
So it means from here to here, the big area is 990, 10. So how do we get this small region? We subtract from 1. So 2.33 negative, we're going to subtract 1 minus 0.990, 10. So here we're going to have 0.0099. So that is how we go about it. So the principle here is whenever the shading is small, we subtract. Whenever the shading is big, we read directly. All right. Suppose we have the same mean of 10. The standard deviation is 3. Then we're being asked to find the probability that x is greater than 4. So what do? We illustrate here. Our 10 is here, our 4 is on the left side. Automatically, we know that this 4 will be a negative because it's on the left side of the mean. All right. Then we are shading on the left or on the right. Where are we shading? Because of the sign greater, we're going to shade on the right. So using ISA, we've only done 3 steps. Illustrate, shade, we now want to standardize and apply. So 4 minus 10 over 3. So 4 minus 10 is negative what? 6. Negative 6 over 3 is negative 2. So this is negative 2 and this is 0. Now the shading is big. Whenever the shading is big, what do? We read directly or we subtract?
Direct.
We read directly, correct. So ignore the sign at the moment. So just check on the reading for 2.0. What do we have? 97725. So this is 97725. Yes, please.
Sorry for taking it back. I want to ask from px greater than 4. And now we are doing it.
The probability x is greater than 4. Using ISA, step 1, illustrate. Our 10 is here and our 4 is there. Step 2, shade. We are shading because the sign is greater. Already able to tell that this sign This area is big. So it being big, our reading will be direct. Step 4, we standardize. 4 minus 10 is 10, divided by 3 is -6. -6 over 3 is -2. So we put the negative on this side. So you have two options here. Number 1, to read from the positive side, you ignore the negative side, because the negative starts from here to here. So the reading you're going to read, if you're using the negative table, you need to subtract from 1 because we are starting from here. But either way, if you're going to read the positive side, it will always give you bigger figures. So the reading you're going to read. So when we go into the table, what is the reading under -2? So -2 here, when you read it here, -2, it is giving you 0.7725. So here, since the shading is big, you don't subtract. But if you can notice, your table has negative figures, if you like. So this negative figure, if you go and check under -2, you give you 0.0275. That reading simply means that it is taking the reading from here to here. Still okay? So, but what you need to do in this case, since the area we're looking for is big, we subtract 1 minus that, it will still give you this answer. It's still the same. Are we together?
I still haven't understood x is greater than 4.
On what? X is greater than 4. X is a variable we are shading. So shade where it is starting from 4, going to the right. Greater means shade to the right. Less means shade to the left. So x greater than 4. So you shade all values that are more than 4. So we can't put 4 this side because 4 is on the left side of 10. Then start shading to the right. If we said x less than 4, we would have shaded to the left. All right. So the key thing is understanding the concept here. Mean is 10 and standard deviation is 3. Suppose they asked you to find x is greater than 19. So let's use ISA. What do we do? Illustrate. Where is our mean? At 10. And 19 is here. So where are we going to shade?
On the right.
To the right. Why? Because the sign said greater. So what is the next step we do? We standardize. How do you standardize? X minus mu over standard deviation. So 19 minus 10 divided by the 3. So 9 over 3 is 3. So meaning the 10 is at 0, the 19 is at 3. So you check in the table, what is the reading at 3? We go to the Z table. What is our reading at 3.0? 99.86.5. So it means from here to here is 99.86.5. So how do we then find the shaded region? We subtract. So this would be 0.00135. So you need to understand the concept, when to subtract, when to redirect. That's where most people have an issue. All right. Before I go to exam type questions, let me also take you through intervals. The mean is 10. The standard deviation is 3. They ask you to find the probability between 7 and what? 16. So in this case, we're going to rearrange it there. So our 10 is here, our 7 is here, our 16 is there. So we're going to shade this region. The mean is always at 0. So how do we standardize the 16? 16 is what? 16 minus what? 10 over 3. This is 6 over 3. We get a what? A 2. Then the 7, how do we standardize the 7? 7 minus 10 over 3, which is what? Negative 3 over 3, which is negative 1. Now, whenever we're dealing with two intervals, you're advised to find the values of x in the table, you add them and subtract the 1. So let's start with the value of what? 1. That is assuming that you're only using a positive table. Mind you, there are a number of tables that you'll be given. It depends on how you read them.
Sorry, I haven't understood anything on this question.
On this what? Intervals.
I haven't understood anything.
Right, so when you're dealing with intervals, we're looking at the area in between. So we're being asked to find the probability of between 7 and 16. So firstly, we identify where the 10 is. The numbers below 10 is the 7. The numbers above 10 is 16. So we want to look at the probability that lies in between there. So the first thing is you need to standardize the 16 and the 7. So how to standardize 16? We use the same general formula. Z is equal to what? X minus mu over standard deviation. Are we together so far?
Yes, yes.
So to standardize 16, it is 16 minus 10 over 3. So which is a 2. To standardize the 7, 7 minus 10 over 3, which is a negative 1. So my tricky point at this point is read these values in the tables. So I don't know what you're comfortable with. If you're reading them as they are from their tables, just subtract the bigger number from the smaller number. So let's start with negative what? Negative 1. What is the reading under negative 1? So you go to negative 1. The reading under negative 1 is what? 0.15866. 15866. 15866. What is the reading for 2? We'll go here on the positive side. The 2. 0.97725. And subtract these 2. Minus 0.15866. So here we're going to get 0.81859. So this is how we find the difference between two intervals. This is how we find the difference between two intervals.
Okay, I understand.
Suppose we're asked to find the probability between 13 and 19. Same thing, you just find, illustrate them. The 10 is here, the 13 is here, the 19 is there, in between there. So how do we standardize 13? 13 minus 10 is 3. 3 over 3 is 1. 19 minus 10 is 3. 9 over 3 is 3. So we're trying to look at the probability between 3 and 1. So if simplifying the probability for Z is equal to 3 minus probability of Z is equal to 1. So we're going to check under 3. So you check under 3 there, 3.0, 99865. 99865. Then you check under 1. 841.34. So 0.841 for the difference between these two. So 985 minus 0.84134. So the difference is 15,731.
Where did you get the 3 and 1?
Where did I get the what?
3 and 1.
When you standardize, it's 13. So 13 will be what? 13 minus 10 over 3.
19 minus 10. Okay.
19 minus 10 over 3. Okay, which is 3. So that's why we get them. All right. So mu is 10. Standard deviation is 3. But A, I want somebody to help us find the probability that X is greater than 14. But B, I want somebody to help us find the probability that X is greater than 5. And part C, you can lead us through, or you try first. X is less than 4. So try this one, I'll give you a few minutes.
That's how.
Okay, so for the first one, where are we going to put the 10?
In the middle.
14?
And then put right side.
The right side, correct. Where are we shading?
We're going to be shading on the right side because of the greater sign.
Correct.
We're going to say to standardize rather.
Correct.
So that's going 14 minus 10 divided by C is 1.33.
1.33, correct. So 10 is at 0 and 14 is 1.33. Then
we're going to find the value on the table.
we go to the table, correct, and identify the value of 1.33. So what is the value of 1.33?
0.90824.
90824. So this is 90824.
And then because the shading is small, we're going to subtract we subtract from 1 to find the value for the other side as well.
Good. So where we're subtracting because the shading is small. So we can say probability of X greater than 14 is 1 minus 1.90824, which gives us 0.09176. Excellent. I like the way she has put it. My language. Next, part B.
Okay, so for the same, similar to what we did for the first one, except this one is going to be going from 5 to 10.
All right.
Yes. We are going to be shading on the right side.
Where's the 5? On the
The
left,
5
on the
is
right
on the
side of 10?
it's on the left side of 10.
Okay.
Then we are shading on the right side, so that's going to be
This
this side.
side.
Yes.
Mm-hmm.
And then we are going to standardize.
Okay.
That's going to be 10, 5 minus 10
Mm-hmm.
divided by 3
Mm-hmm.
is negative 5 divided by 3, giving us negative 1.67.
Good. Why not 1.66? You round off the next 2 decimal places to read in the table. Yeah, I'm glad you were listening.
And then we are going to the table to find the value.
Okay, 1.67, give me the reading.
1.67 is 95254.
95 to 54, correct?
Yes. And then since the shading is big, we're going to go there. Just like that. You
Good.
don't subtract.
If the shading is big, you get the positive side directly. Because all positive values have what? All positive values have numbers bigger than 50%. So here we have 95 to 54. So 95 to 54. So since the reading is from here to there is big, we're going to take it as it is, 95 to 54. Correct. Even if this is showing a negative 1.67, but if you want to use the other table on principal basis, if you're going to get negative 1.67 on the negative side, you go here, negative 1.67, it will give you what? Negative 1.67 will give you this figure here, 0.04746. So that one just means it's just here, 0.04746. So just giving you the area for this part only. All right. So here, automatically you need to subtract 1 minus 30 to give you the remainder. So be careful on how to use the tables. It's the same principle. Are we together?
Yes.
Right, lastly, how do we move with an interval of between 14 and 4? So you are going to use intervals. Our 10 is here. 4 is on the left side. You need to give us a negative side, and our 14 is on the right side. So the 4 here, we already standardized. We found a negative 2. The 14, we found 1.33. Then here, I would advise just read them directly from the table as they are and subtract them. -2, you go to -2. -2, you find 0.02275. Then here, for the 1.33, you got the positive side, 1.33 here, you get what? 90824. We subtract these two. All right, that is the interval. Are we following? Are we together?
Yes.
Right, so we're going to look at an exam type of question. Let me send it to the group. Any questions while some
So for the one that's going to be dealing with ranges, it doesn't really matter what sign is there, you automatically say it in the middle.
yes, the ones with ranges, you
Okay.
if you read them directly, it doesn't matter. So I've just simplified your work. So I've sent you the way the questions would come. So define the three characteristics of normal distribution. Who remembers? So bell-shaped, they're symmetrical, area under graph is equal to 1. Question number 2, speeds at which cars pass through a checkpoint assumed to be normally distributed with a rate of what? Mean 61 miles per hour. And our standard deviation is 4 miles per hour. So our mean, this is our mean, 61 miles per hour, and the standard deviation is what? 4 miles per hour. So what is the probability that it will be slower than 65 miles per hour? That's the probability that it will be slower than 5 miles per hour. What do we do? Right. So in this question, we have 61. That is our mean. Our standard deviation is what? 4. Then what is the probability that it will be traveling slower than 65? The probability X slower is synonymous to what? Less. Okay. So mu is what? 61. Standard deviation is what? 4. Then part A, we did that it will be slower than 60 what? 64 miles per hour. 65 miles per hour. So what do we do here? We illustrate. Just all these questions have now been put in applied perspective. Then here we have what? 65. Why are we using less? Because of the weight slower. Okay, which side are we shading? This side. So 0, and then here you standardize. Okay. 65 61 over standard deviation, which is 4. That's 4 over 4, which is 1. Then read under the table. I'm not going to answer the questions, that will be your homework. So, just a concept. What's the probability that it will be more than 66 miles per hour? It's greater than 65. What's the probability that it will be less than 69? Less than. More than 58 per hour? Greater than. Okay, given selling prices of homes is given by 276 and 32. What's the probability that there'll be more than 206? So it's greater than 206. Less than 220, you put less than. Between 250 and 350. Remember, I gave you the confidence between the two intervals. You know what to do, right?
Yeah.
So when you go there, in case you are lost, at the end of this, there's a video, just click it. It will take you through today's lesson. I've explained everything in there. Have a great day. Unless there are any burning questions.